Hey there, and welcome to another day of chemistry with Miss Stanley. Today we are going to be working on our LT12 atomic structure. So let's grab that document. Go to your chemistry course and go to Unit 2. Go to your notes and click LT12. I know you've gotten to this point, so go ahead and open up my document. You should be in an ed puzzle. There's going to be an ed puzzle right there that you should have already clicked. Awesome. And let's get started. I'm going to have this open on one page. One moment while I gather this document. Make sure that you have this ready and open. All right, so on one side of your page, you should have your document open, and on the other side will be my video, so you can have your ed puzzle up here. And then I'm gonna demonstrate that by putting it here. And then another thing what you'll do is you'll have your simulation pulled up. So let's go ahead and do that. Here's your bell ringer. Pause the video here and let's go find these definitions. Good job. All right, our next slide says to go to this website. We're going to left click and open the link. And we're going to pull this simulation down here. All right, and it says to press the play button. So let's press the play button. And it says to select atom. So do you see how it says atom right there? We're going to click atom. All right, and now let's see what we're going to do. It says click the green plus arrows by net charge and by mass number. Perfect. And it says place a check mark in the box for stable, unstable in the show selection. Perfect. And let's explore. All right, let's see what happens when we throw a proton in. Ooh, interesting. Happens when we throw a neutron in. Huh. Interesting. And an electron. Ah, that was weird. It wouldn't go to the center. All right, so let's fill in this chart. When we threw in the proton, let's take everybody out. When we threw in the proton, watch this net charge. Watch this net charge. Let's see, does it change? Oop, it does change. Go ahead and add that to this document. Let's look at the neutrons. Let's see, watch the charge button. Huh. So when you add the neutrons, the charge does not change. Let's see about the electrons. But the electrons do change. Oops. All right, go ahead and add those for our charge category. Does the charge change? Awesome. Now let's talk about the mass number. I'm going to reset this. Plus, and check. Let's see. When I add a proton, does the mass number change? When I add a neutron, does the mass number change? When I add an electron, does the mass number change? Go ahead and answer those accordingly. All right, the location. When I'm adding protons, every time I add one, it goes directly to the center. The center is called the nucleus. The nucleus, okay? Nucleus is spelled N-U-C-L-E-U-S. The nucleus, all right? The nucleus. So the neutron, when we throw the neutron in there, it goes to the same place. So make sure you have nucleus on both of those. But the electrons, on the other hand, they go to this outer place. This outer place is called the electron cloud. Electron. Ooh, that's bad. Oh, that's bad. That's real bad. Oh, that's real bad. The electron cloud. One moment. The electron cloud. Good. All right, you should have this filled in now. Question 2 says, which subatomic particles contribute to the mass? Well, if we look back at our old work right here, we know which of these affect the mass. When we added the proton, it affected the mass. When we added the electron, it affected the mass. All right, so if I look back here, I see that my proton changed the mass and my neutron changed the mass. So if I go over here, which subatomic particles contribute to the mass? Well, that's going to be my protons and my neutrons. It says which subatomic particles contribute to the charge? Well, let's go look. Which two change the charge? Good. That is going to be my protons and electrons. Good job. All right, the definition of matter is anything that has mass and takes up space. Are there any of the subatomic particles that appear to defy this definition? Come up with an explanation with your group, which you don't have a group because you're watching my video, to explain why this may be happening. All right. Which of our subatomic particles, when we added them, did not change the mass number? Well, let's see. When I add the protons, the mass number increases. When I add neutrons, the mass number increases. When I add electrons, the mass number is not increasing. So, I wonder why that is. When we add the electrons, the mass number doesn't move. So go ahead and make your best guess. Do not just have one word for this answer. Go ahead and make your best guess. All right, number 5 says make an ion with a -1 charge. Well, look at this. We already have it. Which subatomic particle, proton or electron, needs to be added to make it neutral? If I'm looking at my net charge here, to be neutral, my positive things equal the number of negative things. So right now, I have one more negative thing than I do positive. So which subatomic particle can I add to make a positive change? Let's see. If it's the neutron, no, it didn't affect my charge. So let's see. Boom, a proton. Good. Once you've changed the ion to be neutral, is it still an ion? Well, let's see. I'm going to remove a proton. It's now called an ion. Let's see. Let's add a proton. Oh, the name changed. What did it change to? Good. Besides the charge, what else changed after the addition of the subatomic particle to make it neutral? All right, this is what it looked like before. We have a charge of -1, a mass number of 15, and it's called carbon. And we have a negative ion. Boop. What 3 things did you notice changed? Go ahead and put those here. What 3 things did you notice changed? All right. Number 6. Number 6 says starting with the neutral atom, which is what we have. Which subatomic particle needs to be added in order to change the charge to negative? Well, we know that the proton makes it more positive. Let's see if it's the neutron. Go ahead and try. Nope, that didn't work. Let's try the electron. Ah, the electron changed the charge to be more negative. All right. Here's the question though. Does the identity of the element change when you went from neutral to negative? Right here, I have nitrogen. I'm going to add an electron. It's still nitrogen. So no, it did not. Which subatomic particle will change the charge without changing the identity? To summarizing question, when we added the electrons, it did not change the identity. So our answer here will be electrons. All right, let's look at slide 9, number 7. If an atom has 6 protons, what element can it be? Let's reset here and add 6 protons. What element do you find it to be? Good job. Go ahead and place your answer here. It is carbon. When electrons are added, can they be added in orbits of any order, or is the order set? Let's see. I want this one to go on this outer ring. Oops. Looks like it won't let me. Okay, but let's try now. So it went that time, but the first two had to go to the inner circle. So what's my answer here? Is the order set, or can you put them in any order? All right. Now my favorite part. If I'm looking at this neutral atom, let me go ahead and make a neutral carbon atom here. I notice that my electrons go into this model in 2 different ways. The first one is they fill this inner orbit with 2 electrons. Then the rest go on this outer circle, this outer ring. Well, we have this thing called valence electrons in chemistry. And valence electrons are the outermost electrons. Valence electrons are the outermost electrons. And valence electrons are the outermost electrons. Valence electrons are the outermost electrons. Go ahead and add a text box here and write that in. Valence electrons are the outermost electrons. Yes, yes, yes. Valence electrons are the outermost electrons. Yes, they are the outermost electrons. Okay? Valence electrons are the outermost electrons. They are literally the ones that are on the outermost edge. So look here. Right here. How many valence electrons do I have? This outermost ring. How many valence electrons are there? Good. All right, since we already have carbon built, we're going to work this example down here. Carbon has 6 total electrons. 1, 2, 3, 4, 5, 6. Now, when it is talking about, um, which ones do I have, then we are looking for this first level. This first level is this innermost ring, and there are 2 electrons in that innermost ring. The second level is this outermost level, and we have 1, 2, 3, 4. All right, we have 4. And if you remember my lovely chant that I just screamed at you, valence electrons are the outermost electrons. That means that valence electrons are going to be those outermost electrons. And I have 4 electrons on that outermost level, which means I have 4 valence electrons. Beep, 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 bow. All right, so now we need to go for boron. your steps are to add protons until it reads boron. It took us 5 protons, and it told us that we need a neutral atom. A neutral atom. Well, if I have 5 positive things, I'm going to need to balance it out. So I'm going to balance it out using 5 negative things. And the negative subatomic particle is the electron. 1, 2, 3, 4, 5. Boom, I now have a neutral atom. A neutral atom is great. So let's do the thing. Let's count them up. Let's count them up. Let's COUNT count them up. All right. How many total electrons do I have? Tell me. I want to know. Ooh, I have 5. Good. How many do I have in that inner level? I have 2. How many electrons on that second level? Yes, good. I have 3. And that means I have 3 valence electrons. Pew, 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 pew. Pew, 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 pew. Pew, pew, pew. Good job. All right, finish this up. Next up, it says change the model from orbits to cloud. Right now it says orbits. Let's make it cloud. Oh, whoa. Whoa. Interesting. What do you notice has changed? Go ahead and add your guess there. Now let's talk. It says the cloud model is currently the accepted model of the atom, which means it's more accurate. Why do you think that this model is still useful? Why would this model still be useful? Go ahead and put your guess in. Good work. All right, I need you to go ahead and do this. Subatomic particles are protons, electron, and the neutron. Your charge, your proton is positive, your electron is negative, your neutron does not have a charge, so we put a 0. The proton is in the nucleus. Ooh. The electron is in the electron cloud. And the neutron is also in the nucleus. Alrighty, awesome work. Last but not least, to kind of summarize what we've been doing this whole 9 weeks here, we're going to do an atomic model project. Go ahead and click this rubric. Just kidding. What I'm going to do is I'm going to make another video about this project. So go ahead and press submit on this. Press submit, press submit, press submit. Turn it in, turn it in, turn it in, turn it in, turn it in. Have a good day.